Hi guys, today we're going to look at a new lesson called the quadratic formula. Um, so first I want to talk about what it means to solve a quadratic equation. So if you have a quadratic equation such as like x squared minus 5x plus 6 equals 0, and someone says to solve this, right? To solve you would have to factor. So you look for a GCF, there's none. Factor into two binomials, x, 2 times 3, and same signs, so negative, negative, x minus 2 is 0, or x minus 3 is 0, x equals 2, x equals 3. Right? What we've done is we have found these are the concept of the roots. That means that the parabola is intersecting the x-axis at 2 and 3. Here and here, at positive 2 and positive 3, that those are my roots. So the ones that we can factor, like we've been doing, are because the roots are integers. They're positive or negative whole numbers. Sometimes the roots are not nice, neat integers. Sometimes the roots are numbers that are really long decimals, which we call irrational numbers. Right? So maybe like the root is, instead of 3, maybe it's like 3.1297. That's an irrational number. So if you look at, for example, skipping down to example 1 down here, if you tried to factor this, right, and you tried to go, okay, what's the GCF? None. And I go into two binomials, I look for factors of 4, 1 times 4, 2 times 2. Neither one of these pairs is going to add to give me 7 or negative 7. So that's because my roots are not integers. My roots are these long decimals that go on forever without any repetition. My roots are irrational. And so I can't factor to solve. And that's when we use this other method called the quadratic formula. Right? So factoring is not going to work here. The quadratic formula is long, so you definitely, like, if you can factor something, you want to factor it. That would be like your best method. But if it's not factorable, like in example 1, we use this method called the quadratic formula. So the quadratic formula looks like this, and it's something that you're supposed to memorize. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So the a and the b and the c are referring to the ax squared plus bx plus c that we had talked about when we were factoring, and with the quadratic functions when we were looking at the a value, and the c value is the y-intercept. The a value tells you how wide it is, if it's open up or open down. Those values go into the quadratic formula. And if you just plug those numbers in and solve, you will end up figuring out what the roots are. You'll get these values. We only want to use this because it's a long formula. We only want to use it when the roots are irrational, when something can't be factored. So I'll walk you through it. In this example, we would have in the function, in the equation x squared minus 7x plus 4 equal to 0, I would first want to identify what are my a, b, and c values. So a is 1, because that's the coefficient of x squared. B is negative 7, because that's the coefficient of x. And c is 4, that's the constant. Once I've identified those, I'm going to plug into the quadratic formula. It's going to look like this. X equals, now it's negative b, so 7 is already negative, so negative 7 turns it into positive 7, plus or minus the square root of b squared, use parentheses, otherwise it's wrong, negative 7 squared with parentheses, minus 4 times a is 1 times c is 4. Notice my square root sign is long. It has to cover the whole thing. All divided by 2 times a, which is A is 1. Okay, in the next line, I'm just going to simplify it a little bit more. That's all we're doing each time is we're simplifying. So in the next line, I have x equals 7 plus or minus the square root of, now negative 7 squared is positive 49. 4 times 1 times 4 is 16. Sometimes it's going to be minus the answer 16, sometimes it'll be plus, depending on how many negatives are multiplying here. If you only have one negative, one minus, nothing else is a minus, and this will stay a minus. If you have an odd number of negatives, this will be negative. If you have an even number of negatives multiplying, this will turn into a positive. Okay, we'll see other examples like that. All divided by 2 times 1 is 2. So notice it's getting simpler, and I'm just basically working with what's under the square root, trying to simplify it. So my next line is going to be x equals 7 plus or minus the square root of, and I'm going to subtract 49 minus 16, which is going to be 33, all divided by 2. When you get here, you now have two paths that you're going to take, two problems that you're going to solve. One of them is with the positive up here, and one is with the negative. So you set up two problems. Either x equals 7 plus the square root of 33, all of it divided by 2, or x equals 7 minus the square root of 33, all of it divided by 2. So in your calculator, you are going to type in first the whole numerator, hit equals, and then divide that answer by 2. So I'm typing in 7 plus the square root of 33 equals, I got 12.74456. I leave the whole decimal on my calculator, and then I divide it by 2. And so your answer is going to be, for the first root, 6.3722. Now I have to tell you what to round to. So in this case, I would say like round to the nearest tenth. So 6.372 will round to 6.4. That's my first root. My second root is 7 minus the square root of 33. So 7 minus the square root of 33 equals, hit equals at the top. It gives me 1.2554, blah, blah, blah. Now divide that answer by 2, and you get 0.6277. So to the nearest tenth would be 0.6. In each problem, I'll tell you what to round to. So these are the two roots. They're the intersection of the parabola with the x-axis at 0.6 and 6.4 approximately, but the roots are irrational. Okay? On my answer key, you'll see my answer is expressed like this. X equals, and I'll use braces because I'm making a list, 0.6 and 6.4. All right. So if you want to use braces, you can. If you want to list them separately like this, you can. So we'll take a look at another example. In example 2, okay. In example 2, I have an A value of -2, that's here, a B value of 8, that's here, and a C value of 5. So I'm going to go into x equals -b, -8, plus or minus the square root of b squared would be 8 parentheses squared minus 4 times a is -2 times c is 5, all divided by 2 times a, which is -2. And you just go simplifying. -8 plus or minus the square root of 8 squared is 64. Now this is the part I was talking about before. If you count the number of negatives, you have a negative and another negative. If you have two negatives, an even number of negatives, you'll be adding. It's kind of a quick way of figuring out if this is going to be a plus or a minus. And then just you can now ignore the signs and just multiply 4 times 2 times 5. 4 times 2 is 8 times 5 is 40. So it would be 64 plus 40. All of it divided by 2 times -2 is -4. So x equals -8 plus or minus the square root of 64 plus 40 is 104. All of it divided by -4. I'm now going to have two paths. Either x equals -8 plus the square root of 104, all of it divided by -4, or x equals -8 minus the square root of 104, all of it divided by -4. So in my calculator, remember to hit equals for the numerator first. So I have -8 plus the square root of 104 equals, I got 2.198, and then divide that by negative 4. That's going to give me x equals negative, and I said round to the nearest tenth, negative 0.5. It was really 0.5495. And then for the second root, I have negative 8 minus the square root of 104, which is negative 18.198. Remember to hit equals, and then divide that by negative 4, and that's going to give me positive 4.5 to the nearest tenth. It was 4.595. Okay, now the next one is a little bit tricky because if you look at the way it's set up, the first, the way that the equation is initially set up, it isn't set equal to 0. So that's something that you have to do. You have to set equal to 0. So you would need to subtract the 1 over 9x squared plus 12x minus 1 equals 0. Then you could determine, okay, my a value is 9, because that's 9. My b value is 12, because that's 12. And my c value is negative 1, right? Not positive the way it looked in the beginning, but negative 1 when you move it over and set it equal to 0. So feel free to pause me at this time and try to see if you could do this on your own. X equals negative b, negative 12, plus or minus the square root of b squared, 12 squared, minus 4 times a is 9, times c is negative 1, all of it divided by 2a, 2 times 9. X equals negative 12, plus or minus the square root of 144, and I'm going to count my negatives. I have 2 negatives, so it'll be plus. If it's an even number of negatives, it's positive. If it's an odd number of negatives, it's negative. And then I have 4 times 9 times 1 is 36, all divided by 18. X equals negative 12, plus or minus the square root of 144 plus 36 is 180, all of it divided by 18. I now set up my two paths, x equals negative 12 plus the square root of 180, all divided by 18, or x equals negative 12 minus the square root of 180, all of it divided by 18. So negative 12 plus the square root of 180, hit equals, then divide by 18. That's going to give me a root of, and now I'm rounding to the nearest hundredth, 0.078. It's going to be 0.08. And then negative 12 minus the square root of 180, divide that by 18, is negative 1.41 to the nearest hundredth. Okay, we'll do one more. This one is like pretty much the same idea as what we just did. It isn't set equal to 0, so you have to set it equal to 0 first. So you guys have to subtract x and add 8. So this is really x squared minus x plus 8 equal to 0. Now I could figure out my a value is 1, because that's there. My b value is negative 1, because of that number, the coefficient of x, and my c value is 8. Now I go into quadratic formula. X equals negative b, so negative 1 is positive 1, plus 1. Plus or minus the square root of b squared, use parentheses, otherwise it's not correct, negative 1 squared, parentheses, minus 4 times a is 1 times c is 8. All of it divided by 2a, 2 times 1. So x equals 1 plus or minus the square root of negative 1 squared is positive 1. And here I only have one negative. So if I only have one negative, my answer will be minus 4 times 8 is 32. All of it divided by 2. Now in this situation, you notice that you get here, when you go to simplify this, you get a negative number. You're going to get 1 plus or minus the square root of negative 31. Right here, you can stop. If you come across this ever, you cannot take the square root of a negative. We already know that. That tells you that there are no real roots for this quadratic equation. That's telling you that the parabola is not intersecting the x-axis at all, and that's why you're getting something that can't be solved. So your final answer would just be no real roots. Okay, and that does happen sometimes. So just, that the situation you'll come across is that you're trying to take the square root of a negative. And what it means is that the parabola is not intersecting the x-axis at all, so that's why there are no real roots. All right, guys, so you're going to practice a couple of these tonight, and they're all pretty much like the same routine as what you see me doing here. All right, thanks, bye.